Hello, welcome aboard the Tech Genius XY. Don't forget to hit that subscribe button and ring the notification bell for your passport to programming in English and Hausa. Thank you for joining us today. We are in lesson 4, continuation of the previous lesson. So the continuation is all about bitwise and Boolean operations. So without wasting time, let's dive into our presentation. So the learning objectives is also aligned with the previous learning objectives, but with the addition of bitwise understanding and Boolean operation. So let's check the meaning. What is bitwise operation? Are used to manipulate the individual bits of an integer. This definition is very useful, and this is the truth table for bitwise. So this is the ampersand, which is AND operator, and this is OR operator, the pipe sign. Then this is NAND operator, this is NOR operator, this is OR, this is NOT. So by looking at the outputs, the inputs must be 1 here, which is true, or yes, it must be 1 1 before the output will be 1. That is for AND. For OR, it is only when the two inputs are false or no, that is only when the output is no, is false or 0. Any other case, so the same is applicable to the rest. You have to just check the logic behind it, then understand how it's working. So the Boolean operation is all about true or false, 0 and 1. So the combination of operation, we are going to see that in our online interpreter. Then we are coming to the almost the end of the slide. So let's jump to our interpreter. So first of all, I'm going to highlight comments from this line. I'm going to use triple quotation to multi-comment this. So I'm going to multi-comment this. So as you can see, if I run this, only one is going to run. Okay, on unterminated string. Okay, I have assigned. Okay, here I have to, yes, so this error will get, yeah, we don't have any error. So I did not remember to, when I've already test run the code, so I'm supposed to check for the comment, the triple comments. So this is how we use the triple commenting to multi-line, the triple quotation to multi-line our code that we don't want to run or want to skip. So you use this, not the hash. The hash is just single line commenting. So the triple quotation is for multi-line commenting. So as you can see, we comment this, all this line till where we close the quotation. That is where the here, so that is where here, that is where the comment is going to stop. Then I also start another commenting from this line, which is multi-line commenting until where I want to stop. I stop here. Then I also comment this out. I commented this out. So as you can see, it has here, this is where it stopped. So I did different batch of commenting, so depending on what you want to do. So in this case, I want to be running this code step by step. So we are going to start with the bitwise AND. So as we know, bitwise AND is only true if the bit of the number is true. So this 5, this is 5 in decimal. Integer 5, this is 5 integer 5, yes. Then this is the binary representation of the 5. We have talked about that. So this is the binary representation of the 5 because we are dealing with bits. So bitwise operation, that's why it's called bitwise operation. So you have to be dealing with bits, not with the number itself. So the second one, 3, this is the binary representation. Then we carry out the truth table. So we know that it's only going to be true if the input is true. If A has 1 at the end, this one has 1, and then we check for the combination. This is 0 0, this is 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1. So that is why the output is going to be 1. The operator performs a bitwise operation on each pair of corresponding bits. So that is the binary bits here. It returns a new integer with bits set to 1 only. So that is what 1 and 1 here is going to return that. So in any other case it's going to be 0. So that is, this is 00001. You just have to follow your truth table. Then if you run it, you can see we are having 1 here. So the same explanation is applicable to this. So I'm going to comment out, I will remove this string, this double triple quotation, and I'm going to stop the program after this print function. So all the rest of the program is not going to run. So I want to see what will be or. So the bitwise or 5 or 3, this is how you write it, 5 or 3. So after declaring the variable, then we print it out, which is 0 1 1 1 1. That is the binary representation of 7. This is it. So as we see on the interpreter is 7 here. So it's actually working. So let's run the next one. I'm going to remove this and I'm going to stop the program after this. So that is one of the advantage of multi-line commenting. So we just have to like use the triple quotation. So as you can see, we have 6 here after checking for ZOR. So 5, this is the sign for ZOR, 5 ZOR B. So we check the binary representation, which is 0110, and the output is 6. So it's the same thing with the interpreter. So I believe this is self-explanatory till the end of this code. So let's rerun the remaining one. We are running part by part, so that according to what we are explaining. So the XOR operation on a it carries out corresponding bit of 2 integer, then it returns new integer with bit set to 1 if exactly one of the corresponding bits in the operand is 1 as well. So we are going to check for the negation. The flip, we call it invert, so it changes anything from 1 to 0, from 0 to 1. So this is 5. We are negating the 5, we are not 5. So, and this is the symbol for that. So we are going to print it and see what will happen. So let's run this code. So we have -6, as you can see. So let's run the remaining. This is the reason why we have the -6. The binary representation of 1010. Note that the Python used two's complement for negative numbers. So, and this is little explanation on two's complement. I have the code beneath here, so I'm going to stop the operation here. So let's put our comments here. So we are going to check. This is 5. We are converting the 5 to binary with the help of the bin function, bin. Then we are also putting -5, and we are checking the binary representation of that as well. So let's run this program and see. So this is the binary representation of 5, and this is the binary representation of the -5. So as you can see, we are running the same thing and we're having the same output. So this bitwise and, which is the same thing as what we explained previously, and bitwise also. I'm going to run all this program down till here. So let me just put the triple quotation so that the others will not run. So basically this is where the bitwise and or ZOR not. Then left shift. What is left shift? So this is the left shift. We should talk about it. The left shift, it has less than, 2 less than sign. That is how to declare left shift. So what does it do? This operator shifts the bits. So it shifts the bits to the left by a specified number of position. So this is the specified number of position, which is 5. So it has to change this to this 5 to binary, this also to binary, then it do the shifting. So this is the right shift. This is how you declare the right shift, which is greater sign to greater sign. So we are going to see the application where this is useful. So this is a small project which we are going to test run. Is for setting and checking flags. So we want to check if a user has read or write permission. So we are declaring the read as 1, which are the power of 2. This is power of 2, 1 2 4 8. So we declare